So yesterday we solved a system of linear equations by graphing. And the way to do that was you plug in both linear equations, so both lines like this. You hit graph, they intersect, then you're going to hit second calculate the intersect, and it's going to generate an answer for you, like I showed you in the last video. However, there are two other ways to find this answer, this coordinate pair for the answer, and those two other ways are by substitution and elimination. I'm going to start by showing you how to do substitution, but just know in this lesson there are two skills that you need to know. There's substitution and elimination. But let's start with substitution. Here's my pen. And pretend you have the equations 2x plus 5y equals negative 5, and x plus 3y equals 3. So in substitution, what you want to do is take one of these equations and solve it for a single variable, then take that and put it into the other equation. So let's just pick one of these equations. Let's say we got this one. Let's solve this for x. So to solve it for x, we're just going to forget about this one up here for now. Just going to forget about it. Solve for x, you subtract 3y. You get x equals 3 minus 3y. Now what you're going to do is take this answer and plug it in for this x, because that's what x is equal to. You take it and you plug it into the other equation. So you get 2 times 3 minus 3y plus 5y. Now I'm just finishing off the equation, just like it says up here, equals negative 5. And I'm going to do more math, so 6 minus 6y plus 5y equals negative 5. 6 minus y equals negative 5. Okay, minus 6. Negative y equals negative 11. And of course, we can't solve for negative y. We have to solve for y. So we're going to multiply times negative 1. We're going to get y equals 11. So y equals 11. Now what we're going to do is take y equals 11, and we're going to plug it into one of these two equations. It doesn't really matter which one. Let's just plug it into the top, to the second one. Why not? So you have x plus 3 times 11 is equal to 3. So x plus 33 is equal to 3. X is equal to negative 30. And so your answer as a coordinate pair is these two lines will intersect at negative 30. Well, these two lines will intersect at negative 30, 11. Okay, now let's take a look at the elimination method for coming up with the solution. Remember, the solution is that place on the two lines where they intersect. Remember, there's three things that can happen with two equations. Either they can intersect once, like we said, they can intersect once, and that's when we say there's one solution and they are consistent and independent. They can intersect an infinite number of times if it's the same line twice, and then we say they're consistent. Consistent just means there's an answer. And dependent. And there's also when there's no solution, when they're parallel, like this, and that's when we just say they're inconsistent. Okay, so that's just like a little review from yesterday, but I just want to show you the elimination method now. Like I said, there are two skills for today, substitution and elimination. So let's take a look at. Now I'm going to show you the elimination method. Let's say we have the equations 3x minus 7y equals 10, and 6x minus 8y equals 8. So what I need to do in the elimination method is I'm not going to solve for a variable like in the substitution. I'm going to change this whole equation, well, one of them, so that when I add them together, one of the variables gets canceled out. It gets eliminated. So I think the easiest way for me to do this is to change this 3x to a negative 6x. And the way I'm going to do that is by multiplying by negative 2. So multiply everything by negative 2. We get negative 6x plus 14y equals negative 20. Now we're going to add these two equations together to get our new equation, which is going to be 6x and minus 6x, that cancels. Our new equation is going to be 6y equals negative 12. Y equals negative 2. And of course, now we know y equals negative 2. We can just go back and plug it into one of these equations. We'll just choose this one. There's no real reason why I would choose this equation. I'm just going to do that. So we have 6x minus 8 times negative 2 equals 8. 6x plus 16 equals 8. And we get x is equal to negative 4/3. So the coordinate pair, the place where these lines intersect, is negative 4/3, negative 2. Alright, so that's all fine and good, elimination, but what happens in situations when there's actually an infinite number of solutions or no solutions? So take a look at this example. X minus 2y equals 4, and 3x minus 6y equals 8. And remember, you can solve by elimination or substitution. It really doesn't matter. Let's take this and use substitution. So x is equal to 4 plus 2y. Plug this in for x. So 3 times 4 plus 2y minus 6y equals 8. (6y) minus 6y is actually 0, and we're left with this thing that says 12 equals 8. And when you see something that says 12 equals 8, you know this is a lie. This can't be true. So when this happens, we say, this is a lie, there are no solutions, those lines are probably parallel, they never cross, and there's no solution. Let's look at one more example. So let's say we have 4x minus 10y equals 8, and negative 14x plus 35y, alright, equals negative 28. I had to fix that. So let's go ahead and let's use one of those methods, elimination or substitution. I think in this situation, substitution is going to be a little bit easier. I can't think of something that we can multiply by on the top or bottom to make this really easy. Let's just use substitution again. So let's solve this one for x. So 4x equals 8 plus 10y. X is equal to 2 plus 10/4, so 5/2 y. Okay, let's go ahead and plug this in on the bottom. And we're going to get negative 14 times 2 plus 5/2 y plus 35y equals negative 28. Negative 28 minus, see, negative 14 times 5. 14 times 5 is negative 70 over 2 y plus 35y equals negative 28. I'm running out of space here, so hopefully this program will let me drag down the screen a bit. Okay, this should work. Okay, so let's simplify. Negative 70 over 2 is negative 35y plus 35y. So those two are going to cancel out again, but we're left with negative 28 equals negative 28. And in this situation, because that's true, negative 28 is equal to negative 28. This is a situation in which there are an infinite number of solutions.